Students, we are expected to integrate integral of 1 positive x negative 1 over x times e raised to the power of x positive 1 over x times dx. Now I would distribute e raised to the power of x positive 1 over x with 1. So that would give me e raised to the power of x positive 1 over x times dx, and then it's going to be integral x negative 1 over x times e raised to the power of x positive 1 over x times the dx. Now what I'm going to do here is I'm going to take x out. That would give me 1 negative 1 over x squared times e raised to the power of x positive 1 over x times the dx. Of course, over here you got integral e raised to the power of x positive 1 over x times dx. Next I would consider this quantity, integral x of 1 negative x squared times e raised to the power of x positive 1 over x times dx. I will be using integration by parts, uv negative integral v du, that is my formula. So I would set u to be equal to x, du would be equal to dx, and my dv is going to be 1 negative 1 over x squared times e raised to the power of x positive 1 over x times dx. So I would integrate this. For that, again one more substitution is required. Say let p be equal to e raised to the power of x positive 1 over x, and if I were to differentiate, dp is going to give me e raised to the power of x positive 1 over x. Differentiation of x positive 1 over x would give me 1 negative 1 over x squared times the dx. So clearly you have 1 negative 1 over x squared times the dx. So my right side is going to be, in place of x positive 1 over x e raised, we are going to have it as p. In place of 1 negative 1 over x squared times the dx, right? So in fact, so let me add one more step. So this is dp over e raised to the power of x positive 1 over x is equal to 1 negative 1 over x squared times dx. So 1 negative 1 over x squared times dx, I can substitute this. But what is e raised to the power of x positive 1 over x? That is going to be p. So this is going to be dp over p is equal to 1 negative 1 over x squared times the dx. So all of this will go into the right side. So as I mentioned to you, I would have to replace 1 negative 1 over x squared times dx with dp over p. So this is what we have got. So the p and the p gets cancelled. This will be giving me integral dp. Integral of dp would give me p. So v is equal to p, but what is my p? So this means v is equal to e raised to the power of x positive 1 over x. So the formula uv negative integral v du is equal to u is x, my v is this, e raised to the power of x positive 1 over x, negative, my v is e raised to the power of x positive 1 over x, my du is dx. So all of this will go in place of this. So if I were to take this as say sum 2, therefore I can rewrite 2 to be equal to integral e raised to the power of x positive 1 over x times dx, positive x times e raised to the power of x positive 1 over x, negative integral e raised to the power of x positive 1 over x times dx. Now clearly positive and negative goes off. So you are left with x times e raised to the power of x positive 1 over x. Now since we are dealing with indefinite integral, you have to add the arbitrary constancy. So therefore, what is the final conclusion? Integral of 1 positive x negative 1 over x times e raised to the power of x positive 1 over x times dx is equal to x times e raised to the power of x positive 1 over x positive arbitrary constancy. So that's the solution.